Hi, my name is Julia, and here I'm going to talk about Lab 5, the human rocket, for Physics 2211. The table of contents here is the introduction, then we're going to talk about air resistance models, then the change in air density, and the change in air temperature, and then our results. So there's this guy, Felix Baumgartner. He jumped from an altitude of 1,200 feet to attempt to break the sound barrier. His max vertical speed was 377.1 meters per second, and it took him 50 seconds to reach that max speed, and then he fell for 4 minutes and 20 seconds before he opened up his parachute, and he weighed 117.9 kilograms, and his parachute was deployed at 2,567 meters. So the air resistance model I'm using is the force of drag is equal to 1/2 times rho, which is air density, times velocity squared, times the drag constant, times like the surface area for drag. So the force of drag is equal to mg, because if they cancel out, there's no acceleration, so you're able to find it when he reaches terminal velocity. And so as you can see, I set that up there, and then I found that the drag constant times the area, since for our computational model we don't need those values, never change, and I found it to be around 1.07. And then the change in air density, where rho is the air density, I found this formula on Wikipedia, and so I used it to calculate it by doing rho is equal to the initial air density times the initial temperature minus height minus the initial height, all times the standard temperature lapse divided by the initial temperature, all to the exponent of gravity times the molar mass of Earth's air divided by the universal gas constant times the standard temperature lapse minus 1. And for the change in air temperature, I used an online calculator to find it. And the starting temp when he was at the 120,000 feet is 249.66 kelvins. And then his final temp when the parachute is dropped is 271.46 kelvins. And so here's the results, and here's my code on on GlowScript, where I basically took the formulas from before and just made it so they updated it and graphed it. You can see that his Y position is actually over 10,000 when 10,000 meters when he actually dropped his parachute at like 2,000 meters. And then his greatest velocity is just under 250 meters per second, which is very different from the actual results. So that's interesting. That probably happened somewhere either in the computation or, not fully understanding the formulas. And there also could have been an issue with the data they tracked in the video and it not relating to the actual computational model. Thank you for watching.